let us look at what? Fajan'S rule. See, what is Fajan'S rule? So the Fajan'S rule, it show the amount of covalent character in ionic compound. In ionic what? Compound or ionic what? Bond. Bond due to polarization of ions. So the Fajan'S rule is what as what? That show all the amount of covalent character in ionic bond or compound due to the what? Polarization of what? Of ions. Let's what? Consider the cation and what? Anion. So here, the size of, how am I going to do it? The size, let me know, put it this way. The size of cation is smaller, and the size of anion is what? Is bigger. So the anion contain positive what? Charge. Cation contains negative what? Charge. But the size, this one is what? What? Cation with what? Small size. Here we have what? And what? An ion with what? Big size. Here now, this is a positive charge and this is negative charge. So when the positive charge of cation is attract the electron of the what? Of anion, the electron cloud of anion will what? Will move toward this side. As a result of that, we have what? This, when the electron cloud is what? Is moved toward what? Toward this side. We now have what? This is what? The cation. When it moves to this side, this one will be what? Will be pulling. Will be what? Pulling the electron toward is what? Itself. So when it's pulling electron toward itself, the cation here will be what? Will be deformed. The cation will be what? Will be deformed. So when the cation will be deformed, we have what? Deform. And the negative charge will move toward this what? This side. Let me make it 5 or 6. Move toward this side. As a result of that, this will now behave like what? We have negative charge here. Here we have positive what? Charge, partially. And look at what? The pulling ability of cation is called polarizing power. When I call it the pulling ability of what? Of this cation, we call it what? For what? Polarizing power. Well, what? the deforming ability of what? Of anion, we call it what? Polarizability. Yes. Let me clear this place first. I'm not satisfied with this. I'm coming. Polarizability. Mhm. This positive charge will attract electron cloud toward itself. So the pulling ability of what? Of cation to pull or to attract the electron cloud toward itself, and this cation will be what? Will be deformed like this. When it is formed, here we have partial positive negative charge, partial positive what? Charge. And the pulling ability of this cation, we call it what? For what? Polarizing power. This polarizing power is for what? For cation. Is the pulling ability of what? Of cation is called polarizing what? Power. And the forming ability of what? Of this anion, we call it what? Polarizability. So this polarizability is what? Is the pulling or is the forming ability of what? Of anion. This one is for what? For cathodes, for anion. So, and the ability or the deforming or pulling or attraction of what? Of electron from cation to the what? To the anion is what we call polarization. Is what we call what? For what? Polar, like what? Polarization. So here now, this electron we have here, all of them we what? We pull, move toward the what? The and what? Anion. Move toward what? To the cation. So the cation we what? The positive charge here, we attract the negative charge here. The process of the what? Of attraction. The electron cloud we have in anion, they will what? They will move toward the what? The cation. When the electron move toward the cation will be what? Will be deformed from circle to what? To dumbbell, to dumb. It will deform or distort. So when it's deformed, the forming ability, polarizability is what? Is the what? The forming ability of anion. That's what polarizability. But polarizing power is the what? Is the pulling what? Ability of cation. So the tendency of cation to what? To attract the electron cloud from what? From cation to himself, we call it what? Polarizing power. Where the what? The ability of what? Of cation to deform toward the what? The anion is we call it what? Polarizability. And the entire process whereby the electron cloud is being attracted toward the what? The cation is called polarization. Polarization is the distortion of electron cloud towards an anion. Distortion of what? Of electron cloud from an what? Anion. Distortion of what? Of electron cloud from an what? Anion to cation. cation. That is what? Polarization. The polarization is what? Distortion of what? Of electron cloud from anion to what? To cation. That's polarization. But the ability of cation to pull electron cloud to its what? To itself is called polarizing power. But the ability of what? Of anion to deform the electron cloud towards anion, towards cation is called polarizability. And the process whereby what? Or the distortion of what? Of electron cloud in anion toward the what? To cation is called polar what? Polarization. I said what? We call it what? For what? Polarization is what? The distortion of what? Of electron cloud we have in what? In anion toward what? Anion toward cation is called what? Polarization. And I said it again that what? This cation have what? The pulling power. The what? The pulling ability of cation, or the tendency of cation to what? To attract this what? This electron cloud into the what? Into himself. We call it what? Polarizing power. For what? Polarizing power. Power. So the polarizing power is what? This polarizing power can be found in what? In cation. Can be found in what? In cation. And we have what? Polarizability. The what? Ability. This one can be found in what? In an what? Anion. The tendency of what? Or the ability of anion to what? To deform toward the what? The cation is called the polarizability. The what? The deforming ability of what? Of anion is called the what? Polarizability. Where the what? The pulling ability of what? Of cation, we call it what? Polarizing power. And the process whereby what? This cation, this anion is being what? Deformed toward the what? The anion, we call it what? Polarization. So the third stage now of this reaction, if we have it in this form, this is the cation, which is what? With positive what? Positive charge. And this one that is what? Deform. That is what? Deform. It will get into what? To get into cation in this form. It will later get into the what? From this stage, second stage, to the third what? Third stage. So when it now gets into the what? To the cation, you will now have what? This is a positive charge. The electron cloud will be what? Will be lie on the what? On this surface. And this is the negative what? Negative charge. And this surface will be a partial negative. This here we have what? Partial negative what? Negative charge. And this man is called what? Pulling. This one is the what? The what? The form. And so as a result of what? Of this, now you can observe that what? This when this deforming or the clouding electron is being touched the what? The The cation we have here. This is what? Cation. This one will be what? And what? Anion. So it will not behave that what? This negative charge is shared with what? With this cation. That is what we call what? The covalent what? Covalent character in ionic bond. So because the is the only covalent bond that is always experience the sharing of what? Of electron. But through the process of what? Of polarization that is occur between the small cation and a large what? Anion, the cation have what? The polarizing what? Polarizing power to attract the what? The electron cloud of the what? Of anion, and the anion now try to what? To deform in order to what? To share the what? This electron cloud with what? With cation. Because the only covalent bond that is experiencing sharing of electron. Here now you can now see that what? The ionic bond A also what? Experience the sharing of electron through the process of what? Of polarization. So from this now, we can now conclude that for what? Polarization, polarization is directly proportional to what? Covalent character. The polarization is directly proportional to the what? Covalent character. That is, the higher the what? The polarization, the higher the what? The covalent character. And you can also have it in this form too. The polarization is inversely proportional to what? Ionic bond, or ionic what? Character. So that is all about what? The polarization of what? Of cation, of anion by cation. So the what? The power, a polarizing power which is experienced by cation, polarizability experienced by add what? Anion. So the next thing now is what? What are the conditions that we can use to what? To determine the covalent character in an organic or in a ionic compound. So next thing is what? To determine the covalent character in ionic bond. So the covalent character in ionic bond can be determined in two way. We know that what? The in polarization of what? Of ionic bond. The anion and the what? Cation we have abi. So to determine the what? The covalent character in ionic bond, we need to consider two ions, both what? Cation, and what? And anion will be what? Will be considered. So first of all now, let's consider cation of different size. The cation of what? Of different what? Of different size. By considering the cation of different size, let us look at what? What will happen here. So after that, we now move to the what? By using what? Anion too. So consider cation of different size. If we have what? A smaller cation, and here we have what? Bigger cation. This smaller cation is this. This is bigger what? Cation. So here we have what? Positive charge. Here we have positive charge. You can see that the size of the cation are what? Are different. So the fact here is the cation that is have what? For this one, it will be easy. It what? It will be easy. It will be easy to pull electron. It will be easy for this one to what? To pull electron because of his what? The small size. So here, it will not be easy, not what? Easy to what? To pull what? Electron. As a result of that, polarizing power is what? Is high in a cation of what? Small charge. Here, the polarizing power here, power is what? Is low. Because of the what? Of the bigger size. And I said the polarization is directly proportional to the what? Covalent character. So once the what? The polarizing power is what? Is high. Here again, the covalent character is also what? Covalent character is also what? High here. So the covalent what? Character here is what? Is low. The first things now to determine the covalent character in what? In ionic bond. The first thing that we consider under cation is what? The size of what? Of cation. Cation is small size. We experience the higher polarizing power. It's the pulling power will be high. Then the covalent character in it will also be what? Be high. Compared to the cation with big size, we experience what? The weak polarizing power, and the covalent character in it will also what? Also low. The next thing is what? The first one is what? By consider the what? The cation of different size. So the second one is what? I will say what? The number of charge in cation. So the number of charge in what? In cation can also determine the what? The covalent character in ionic what? Ionic bond. Take for instance now, if you have what? At this level, this one cation, this is second cation, they are of the same size this time around. Abi? But in terms of what? Of charge. Say we have 1, 2, 3, 4, 5, 6, 7 charge here. In terms of charge, we have 1, two charge here. The charge density here is more than what? The number of charge you what? We have here. So the one that have what? Many charge, it will be what? Easy for him to what? To pull electron toward his what? Toward himself. So the more the what? The charge, the easier the what? The pulling of what? Of electron. Easily what? Pulling of what? No? Let me rub it. Electron pulling will be what? Will be easy. What? Here now. One, electron what? Pulling will what? Is easy here. But here, electron what? Pulling will be what? Difficult. Cut. Or is not easy. And here, there's half more charge. Polarizing power will be what? The power is what? Is high. And what happened here? Polarizing power is low. And the third one here, when polarizing power is high, covalent character also what? High. The third one here, what? Covalent character is low. Hello? Once again, it's not like magical. To determine the covalent character in an ionic bond by Fajan'S what? Fajan'S rule. He said that what? Cation with small size we have what? The higher pulling power. And it will experience what? The higher covalent character compared to the cation of the what? Of big size. The second one is what? He said that what? The cation with higher number of charge will experience what? Highest degree of what? Of the pulling power and a more covalent character compared to the what? Cation of the what? Of less charge. Let us look at what? Two or more questions here. How to use this Fajan'S rule to what? To solve question before I will move to the what? To determine by what? By anion. Let us solve this question, please. Take these questions. Let me use this side. Let me use this side for the question. Say what? Which of the following ion we experience more covalent character? Which of the what? Following what? Ions or cations? We what? We have more covalent character. We have lithium plus, sodium plus, and potassium plus. Which of the what? Of this ion will experience more covalent what? Character. Yes, good. Which for you to what to tell me the what the ions that is have what more covalent character, we now need to what to go back to the what the first rule here, which is deal with what the charge of what the size of what of cation. The first rule state that what here that the larger the size or the smaller the size of cation, the higher the what the polarizing power and the higher the what the covalent character. Here is what the summary of this what this first law. It said that what the smaller what the cation lead to what lead to higher the what higher lead to the what higher the polarizing what power, and also lead to the what higher the what covalent what character. So cation of small size must experience big covalent character, and we also have what higher polarizing power. So to solve this now, we have to which of the following ions has what the higher or the more covalent character. Check it now. Here, this is sodium, lithium. Lithium is atomic number 3, sodium is 11, potassium is 19. Draw the KLMS shell. Here we have what 2, 1. Here we have what 2, 8, 1. Here we have 2, 8, 8, 1. By draw this shell here, we have what 2 inside, 1 here. Draw this one. We have 2 here, 2 here, 8, 1, 2, 3, 4, 5, 6, 7, 8. The third one is what? Is 1. So here we have what? 2 inside. We have 8. We have another 8. We have another what? 1. Can you see it now? So this one has 2 shell, 3 shell, 4 shell. Which of the 4 do you expect to be what? To be have big size? And again, the atomic size is increased down the group. So you can see that what? With these 3 elements now, the potassium is what? It's a bigger size. Followed by what? This, and a lithium is a what? It has what? The smaller size. And the element, the cation that has smaller size is the one that have what? The higher polarizing power, the one that have what? More covalent character. Therefore, the lithium is the one that have what? More covalent what character. You can now arrange it in this form that lithium is greater than what? Sodium. Sodium is greater than what? Without what? Potassium. This is what? Increase in what? And covalent character. So the answer will be what? Will be A. That's how you can use what? The Fajan'S rule to solve question. The second question is this. Which of the following, I said this at all. Look at it here now. Fajan'S rule. I said it showed that it show the amount of covalent character in the ionic what? Compound. So that's what we apply here now. And the second one, which of the following ions will experience the higher what? Covalent character? Which of the following what? Ions will experience the higher covalent what? Or more covalent character? Let me say what? We experience higher covalent what character? We have sodium, Na plus. We have magnesium, 2 plus, and then we have aluminium, 3 plus. We are now asked that what? Which of these 3 elements will experience what? The more covalent what? Character. That's where we apply the what? The second rule. We say that what? The number, the cation that is have what? The more charges is the one that experience what? More covalent character, and we also have what? High polarizing what? Polarizing power compared to the one that have what? Least charges. Which of the 3 have what? the higher charges here. And if you look at them, well, here now, we use what? Shell to determine the what? The size. So this time around, these three, they have the same size. Look at it now. This one is 11, one is 12, one is 13. This one, it will be what? 2, 8, 2, 8, 2, 8. They have the same size. So if they have the same size, I do put it here, they have the same size. If they have the same size, you consider the what? The number of what? Of charge. So which one have the number of charge is what? Is aluminium. So this aluminium is one that experience more covalent what? Character. So if you have to arrange them, it will be what? Aluminium plus greater than what? Magnesium 2 plus. Magnesium greater than what? Sodium 2 plus. That is how we can use what? Fajan'S rule to determine the covalent character in what? In cation. So the last one now is what? Let us use what? Use, what did I call this one? Let us use what? We have used what? Let's consider the cation of the way this. Tell me this, Abby. Let us use what? Anion. But before we move to the anion, please, I forgot something here. We have what we called what? The pseudo electronic what? Cation. Or we have superhero. We call them what? Super what? Let me write it somewhere here. Super what? Arrow. Car what? Cation. This superhero cation, they are cation of what? Of D block. Cation of what? Of D what? D block element in positive, which is what? Transition element. Like U, Ag, zinc, copper, all the what? D block what? Elements. All this one. Assume we are giving what? A salt. Yes. We have sodium chloride salt. And we have what? Copper chloride salt. You are now asked that what? Which of the two we experience what? More covalent character. You can see that what? This copper is what? Is a superhero cation or pseudo electronic configuration cation. So any element that belongs to the D block element here, automatically their cation have what? More polarizing power and a covalent character. So please note that. So yeah, anion by using what? And what? Anion to determine the what? This. The first one is what? Let us use what? Size of what? Of anion. By considering the size of anion, the first one is we have anion of what? Of small size compared with anion of what? Of big size. So anion of big size. This small size, we have negative. Big size have what? Negative. But this is what? Small what? Small anion. This one is bigger what? And what? Anion. So is the inverse of what? Of cation. So the one that is have what? Small anion, automatically, this one is what? Is not easy to what? To polarize. Not easy to what? To polarize. And it have what? Polarizing power will be what? Low. Polarizing power will be what? Low. And covalent character also what? Low. But in case of what? Bigger is what? It's easy to polarize. polarizing power is what? Is I. Then covalent what? Character is also what? I. Take for example here. Example, you are asked which of the following anion we have more covalent what? Or I covalent character. We are given what? Fluorine, bromine, chlorine, and iodine. Which of the four we experience what? Or we have what? I covalent what? Character. Or we experience more covalent character. Look at it. Fluorine here is what? Is 9. Abi? So if you want to write the what? Figuration of this one, it will be 2, 7. Here we got 2, 8, 7. Here is 2. No. Here is 2, 8, 8, 7. Chlorine is what? 2, 8, 7. Iodine is what? 2, 8, 8, 8, 7. Look at it now. In terms of shell, we have 2 shell here. We have what? In the fluorine, we have 2 shell. Bromine, we have 4 shell. Chlorine, 3 shell. Iodine, 5 shell. So which of the in 4 anion we have what? The biggest size? The biggest size is experienced in what? In the iodine. Therefore, the iodine, the covalent character in iodine is more than what? Character in what? In bromine. Bromine is more than what? In chlorine. Chlorine is more than what? Fluorine. Or in another form, if you are given that what? Which of the following elements or ionic compound will experience more covalent character? A. Sodium chloride. B. Sodium bromide. C. Sodium iodide. D. Sodium fluoride. You can see that what? Sodium is the same. You now try to what? To look at what? The ions here, the one that is have what? Larger size, it will experience more covalent character, which is iodide. The atomic size increases down the what? The group. This is halogen. So the right answer here will be what? It will be C. That is how we can use what? The anion size to determine the what? The covalent what? Character. The second one here is what? Is the number of what? Of charge. The number of what? Of charge in what? In the anion. So that is what? Let me use this place up here. The number of charge can use to what? To determine the what? The covalent what? Character. What is the number of charge? If you have what? Anion of the same size, and inside this one have what? 1, 2, 3, 4, 5. This charge. This one have what? Just 3 charge. So this one that is have what? A bigger what? The highest number of what? Of negative charge, we experience what? High polarizing power. It will experience high covalent character. The one with less charge will have what? Low polarizing power. We experience low covalent character. The one with what? With low charge. The example of this one is also what? Easy. You are asked that which of the following what? Ions will have what? More covalent character. We are given what? Chlorine minus and oxygen 2 minus. Which of the two ions will have more covalent character? The charge here is 1, the charge here is 2. Therefore, the one that have what? The highest level of charge will experience more polarizing power and a more what? Covalent character. But if you are given what? The if you are given this, we have what? We are given what? Fluorine. We are given oxygen 2. We are given nitrogen minus 3. Which of the three will have more covalent character? The one with higher what? Higher charges, which is what? Nitrogen. So that is all about the what? The Fajan'S what? Fajan'S rule. Don't forget that what? I said the Fajan'S rule is the one that is show us how to what? To determine or the amount of covalent character in ionic bond. And it has what? 3 rules for cation, 2 rules for anion. He said cation of small size will have high polarizing power and more covalent character. Cation of what? Bigger size, lower polarizing power with lower covalent what? Character. But anion with what? Bigger size will have more polarizing power. I've done it now. The small one we have what? Lower. The number of charge the same too. So that is all about what? Fajan'S rule. Don't forget, Fajan'S rule is the one that is telling us that what? There is no compound that is 100% ionic. And there is no compound which is what? 100% covalent bond. So, what is the scenario that is used, or what is phenomenon that is we use to what? To determine the covalent character in a what? In ionic compound is what? Polarization. Polarization. And the rules is what? Is Fajan'S rule. But what is the what? The phenomenon that we use to determine the amount of ionic bond in a what? In a covalent bond. Amount of what? Of ionic. Every covalent compound, they also have what? Little amount of what? Of ionic bond in what? Inside their body. What is the phenomenon that we use that to explain that for us is what? Is dipole what? Moment. So that's all about what the Fajan'S what? Fajan'S rule. So the next thing is what? We are now moved to the what we call covalent bond, which is second types of what? Of intramolecular bond or interatomic what? Bond. So please, before we move to the next aspect of chemical bonding, which is covalent bond, I would like to solve these 3 questions, which is the application of the what? Of Fajan'S what? Rules. So, yeah, let us solve the question. Look at the first question, question number 1. Which is solution? Which of the 2 compounds will have high melting points? What is the compound? We have sodium chloride and we have what? Copper 2 chloride. Sorry. So we are now asked to know the what? The one that have what? High melting what? High melting points. See, I forgot to tell you the application and limitation of Fajan'S what? Fajan'S rule. Under application of what? Of Fajan'S what? Fajan'S rule. See, the increase in what? Any compound that have what? In what? Increase in what? Covalent character. A conic compound that have what? Increase in covalent character in a what? In a compound. In a what? In a compound. We all know that what? Increase in covalent character in ionic what? Compound. We know that what? This ionic compound itself is naturally under pressure by ionic compound. They have what? High what? Melting point. And they also have high what? High boiling point, which is what? Is their unique properties. If a compound is ionic compound, must have high melting and boiling point, abi? But if you now discover that what? The compound now have what? Increase in what? Covalent character. That is, covalent character in that compound is what? Is high. This covalent character will what? Will now reduce, increase in what? Covalent character in any compound, abi? Is is what leads to what? Decrease. The what? Decrease in melting point and boiling point. Hello? In normal ground, we know that what? Any compound that is ionic in nature, they have high melting and boiling point, abi? But if the what? The covalent character of the compound is what? Is being increased, it will reduce the what? The melting point and boiling point, because it will reduce the what? The strong electrostatic force of attraction that is exists between the what? The cation and what? An anion. This is the second fact. This is the first fact. Application of the what? Of Fajan'S rule. And again, if a what? A compound is what? Is increase in what? Covalent what? Character. Increase the covalent character in ionic what? Compound. Can also lead to decrease in what? In solubility. What? Solubility of the what? Of the compound. We all know that what? All ionic compound, this ionic compound, we all know that what? All of them are what? Are soluble in what? In polar solvents. So when the ionic compound is being experienced, the higher degree of covalent character, it will now reduce the what? The ionic behavior of what? Of ionic compound. As a result of that, the solubility will what? Will reduce. The solubility will what? Will reduce. And again, the third one, let me use these two to solve the first two questions now. So we have what? Which of following compound will have higher melting points? Automatically, we have sodium chloride and the copper chloride. This sodium chloride is normal cation, and note that what? This copper chloride is what I call what? Super cat what? Cation, which is what? D block what? D block elements. And I said they are what? Automatically all supercation, D block element, transition element, they have high degree of what? Of covalent character as it is abi. So compared to the what? To the normal cation, automatically the covalent character is what? Is high. Covalent character is what? Is high in what? In copper chloride. I now said what? Any compound that is have high degree of what? Of covalent character, we have what? Less boiling point and a what? And a melting point. So what will be the answer now? Answer is what? Is copper chloride. Is one that have what? No, sorry. The one that have it's one that this copper chloride will have what? Less melting point and boiling point. But this one we have what? High what? High melting point and boiling point. What will be the answer now? Answer is what? Is C. Which of following two compounds have iron 3 oxide and iron 2 oxide will more soluble in water? So that one is very easy. The what? This iron now. Look at question number 2. Iron what? 2 oxide ionize to give us what? Fe2 plus OH minus. Where what? Iron 3 oxide will ionize to give us what? Fe3 plus OH what? Minus. Which of the two ions have what? The highest charge density, which is F3. So the F3 will have what? High covalent what character. Anyone that have high covalent character, the solubility will be what? Will be reduced. So more soluble in water will be what? Iron what? Iron 2. And this one too. Which of the compounds have darkness color among these? Yes, the unique feature of covalent bond is what? They have color. Covalent character is what? They have what? Color. So out of this now, which of these will have what? More covalent character? The one that have more covalent character is the one that have what? The what? Highest color. According to the size. Iodide is what? Is one that have what? Highest size. Answer will be what? Ag iodide. So that's all about the what? The 3 questions.